it's calling main, like a function and passing in the text. Play 20 welcome message. So that's another function that's predefined, but we can easily face that. Main, which is content, and content is defined up here. Oh, it takes 2 arguments, a title and a string. And where is it called? Doesn't appear to be. There must be some other magic going on. I think I saw that in routes. It's always funny, you say magic, but usually when a good programmer says magic, they never actually mean magic. They mean, I am not going to go into the details of this. Or they're demoing it live. Okay, so we got that. Yeah. What? Yeah. What's PFM? Sure. Anyway, we're going to go back to the other implementation of index, and I'm going to show you what happens if I pull a literal string main. Oh, cool. So that's how this works. Whoops. Okay, this is the second argument. How I'm going to prove that theory. Wait. Go back to the main index method. Index is that. Your new application is ready. And verify I remember what's going on here. Content is it's expecting an HTML. It should probably be expecting a string. Alright, hopefully the application is recompiled. Probably. Woo! Too many arguments. I understand what's going on. That block in the curly brackets was, I'm not going to explain on applied functions because none of you have ever programmed in another weird functional language and you'll just like start blazing over and this will become a bad talk. But what I can do is in that error message is instead of saying that as a comma and then that, what it actually is another set of parentheses. And the only difference between the previous thing was the curly brackets wrap and block condition off. This may not work, but I think if my understanding of what's going on is correct, that we will not have an error message. We don't have an error message. Yep, like the Swedish check. And it's HTML, and there's style sheets, and the fav icon. Yeah, the fav icon is still there. So yeah, that's what we did. Oh, there's a doc type, you just can't see it.
I see a doc type, just 4 lines.
Yeah, that's odd. I wonder why it's 4 lines down. But it wasn't in the block. Weird template language. Never played with it before. Delete the new line there. Let's try to get rid of those 4 lines. That's like a good endeavor. Hey, yeah, look at that. Hopefully it doesn't think that is a line. So what's that symbol there? That's a parenthesis. So it takes that as being an argument list, and then it just uses it. And just to make sure, so content's nothing special. Content's just a name. So if I wanted to call content body, this is also a very useful practice when playing with things. And I keep thinking I had to recompile it. Fewer new lines, only 2. So apparently there's, I don't think that's actually an error. Like I think that's perfectly within the spec. And that doc type means it's HTML5, wasn't it?
Yes.
As opposed to the previous ones where you had to say doc type string. Okay, so that's cool. Now what's going on in this template file? So we're not even talking about Scala now, we're talking about the weird templating language. Well, I shouldn't say weird, but the templating language that they came up with for Scala. So if I start putting HTML in here, is that just going to work? Alright, so I think I'm going to pass that. Now what we should get when I already saved this is there should be a type error. What? Oh yeah, I'm viewing the source. There we go. Type error. So this is cool. When you do that curly bracket full of stuff, it's not a string anymore. It's an HTML. It's a Play API templates HTML object. So the type that I gave for the template that we're calling, which is main, the type that I gave for that says that body will be a string, but it's no longer a string, it's HTML. So if we change that, the type error disappears. You know what? You know why this is cool? There we go, it's red, so the HTML is being rendered. What this means is your template, this is a templating language that's taking advantage of the features of Scala because you are witnessing a type-safe templating language where you cannot mistake a string for a block of HTML. Does anyone guess why that's important?
Because you don't want your website to show HTML.
Yeah, so if I pull out a string from the database, it's going to have a type of string, and if I try to display it as HTML, all the HTML is going to be escaped because it knows it's a string. So,
Throw an error.
or to throw an no, well, I mean, if it's in a block, it'll throw an error. But if I just change if I change that from being a block to a string, and redo this and redo the types, you'll see that I think that the HTML will be escaped.
So when you pass the data.
Yeah. So I'm going to make this a string, and I'm going to go back to where it's called, and make that parentheses instead of curly brackets, and inside quotes. I don't know if these strings are allowed to have multi-lines, so we're going to do that, and need to escape that. So that's now being passed as a string, just like when it was the string fork. Go back to here, refresh. Will it interpret as HTML, or will it just, bingo, it escapes it. If you view the source, it escapes the HTML. So you can't get strings out of the database and have them magically get placed in there. This is where the types come in handy because it knows a string is different than HTML. I know looking at some Scala database stuff that we don't have time to get into, the Scala has a type-safe way of building SQL queries, where each part of SQL query is a different type. So you can basically use that to in Perl and PHP and stuff, you use placeholders to avoid SQL injection. But if you screw up and you accidentally embedded a variable in your string that sends a SQL, no one's going to catch that. But in Scala's, and many of Scala's libraries, especially the ones used in Play, those kind of type errors will be caught, and you won't be able to have a SQL injection. The time is now 7:38. I basically planned this as a 40-minute talk, which that's been actually working out pretty good. This was a brief demo of the first few steps in writing a Play app. Questions, especially questions about Scala, because I have weeks more experience in that than I do this.
It's not Scala based, but do you know what requirements Play has to run this app? I noticed MVC framework, which I would imagine comes with Play.
Yeah, it's all bundled together. It's all batteries included, Python style.
Well, it should be just a WAR file once you build it.
Oh yeah, and it displays as a WAR file. Also, what I thought you meant by requirements is something that they cover on the Play Framework website, is the actual machine requirements, the resources utilized by Play are scaled linearly. So it uses a little bit of amount of RAM, it uses a little bit of RAM. Scale predictably. Underneath the covers, Play uses a fully asynchronous model built on top of Akka. Combined with being stateless, Play scales simply and predictably.
So it creates a new instance of complicated connection?
Well, probably new Java thread.
No, if it's truly if it's using a stateless server, It'll use non-blocking I/O and asynchronous servlets. So what that means is that it uses a thread pool, and only when there's actual I/O.
Okay,
from the
so it's the
client.
opposite of what I said then. So it's a thread pool, like Apache's old forking model with
Well,
you're running a static
Well,
number of things.
well, nothing will block for the requests. So even if your client's writing to you,
Mhm.
it'll basically have a gigantic select statement going on
Mhm.
and spin through the inbound I/O based on who's writing to what. So that'll allow you to do things like chat apps really easily because you can have 100,000 people connected to you, but you don't need a thread per client connection.
So with Play, is it running solo or do you have to have it running on a web server?
It runs. I think that it runs as its own web server. And how this usually ties in with the existing stuff is you'll use like Nginx or Apache and you'll forward requests.
Okay, so you still have to have something over it to book us into that app.
Well, not really. I can
Well, it
make
depends how you
this.
deploy it.
I can make this run in port 80 if I wanted to.
Well-
Okay, so internal it has its own server mechanisms.
Well, what it'll do
It's
is-
always using it's always using its own HTTP server for at least the requests to dynamic bits. Normally, you probably shortcut you saw in the template the assets that it's grabbing. You would normally, if you're writing this on a regular web server and you wanted performance, you would, well, I mean to click on that. Oh, that's lame. You'd have it so that these requests would hit your Nginx or your load balancer, so that only this HTML that's being produced would hit the web server to play itself. So,
Well, it all depends on how you want to package up and deploy it. You can
do
do it as
people
a-
ever run Javas as fast CGI? That's one thing I wasn't. Do people ever run Java servlets as fast CGI? No,
It's
never
not
done.
worth it. The JVM startup time is too high.
Well, fast CGI starts at once.
Well, because Java's thread model is so good,
Mm-hmm.
it's usually not worth it because fast CGI is basically saying that your startup time's high, and I'll just feed you I/O as things come in, but I'll manage the actual client connections. But
Okay.
Java, especially with the NIO, non-blocking I/O that it
Yeah.
has, there's no efficiency gain for that.
Yeah.
Please hibernate before you crash.
So that was play-ish. I had actually done everything I've done here. I'd actually tested a little bit. The only thing I wasn't sure of was the type escaping of the HTML, which I was pleasantly surprised because I didn't know that was actually a feature. So, I do know that they use the type safety heavily for the SQL. I forget what it's called now because I probably not-
Parameterized queries.
Well, yes and no. The thing about parameterized queries only gets you so far. If you actually model your SQL queries as an abstract syntax tree, right? You just model as a tree of stuff. Then you can do transforms on your queries, and you can manipulate them like data without having to worry about string interpolation errors. So you can go. Well, we actually use this for something in Perlland to generate our schemas from data.
As long as the database server thinks it's a parameterized query, that's all that really matters. Because we, in the Java world, Hibernate and the other one, iBatis, you can do dynamic queries, but before it actually executes in the database, it's sent as a parameterized, so it saves you from all your SQL injection problems.
Yeah. Well, the type system in this will save you from SQL injection problems, even if you're trying not to. It's like you can actually make. That's the other thing I'm saying is it's impossible for the programmer to make a mistake if it's nice and type safe. So we have about 15-20 minutes left in the talk, and I yield the floor to whoever else wants to use.
Whether you use
I have a question.
Yes.
We talked a couple months ago about some new research that showed that Java was as fast as C.
Mm-hmm.
C or C++.
C++.
And I was thinking about this the other night, and it occurred to me that since Java has its own garbage collection algorithms, does that make it a better programming option than C++?
Yes and no.
I'd make the argument yes, but
Depends on the tool.
depends what you're doing.
Java's
You're writing a thing.
Well, like for example, the reason why the Java ends up being faster than C or C++ is if you have like a heavily threaded program, the garbage collection is more efficient than manually doing new and delete, basically. So if you need, but that makes your program non-deterministic. So if you need a deterministic program, you probably be better off with C or C++.
And where you will run into this is I am actually an Android, not a phone, but an actual Android, no William. And I am walking around and I am actually performing surgery on Pete. So I'm performing surgery, I have his head open and I'm putting the drill in and I'm going to implant the morality chip that makes Pete have his morality.
He's a politician.
Yes, he's a politician. I'm planning the morality chip and to make him a decent politician so that he'll obey the 3 laws of robotics. Now, the problem is that I also obey the 3 laws of robotics. I will never through an action or anything cause him harm. It's a human, even if he's cybernetically enhanced. Anyway, performing surgery on him, and I have all these detailed schematics and maps of the human brain where I can do this, and all of a sudden I throw away the subsection of those maps that I'm not longer using, and for whatever reason, my garbage collection routine engages right as the drill is going in, and then he's no longer a politician, he is a vegetable. So you'd probably be better off writing my Android operating system for me to use a surgery Android in something that has predictable garbage collection, which is to say manual, so that doesn't happen.
Now in large Java style deployments, the way you typically cheat that is garbage collections run as a background thread. So depending on how fast you accumulate garbage determines whether or not you have memory pressure and you have to go to a complete dead halt to garbage collect. So typically people, especially with like your modern Android phone, they'll cheat by saying we'll throw extra processing power and memory at the problem, and 99% of the time you don't care. But surgery is probably an excellent example of when you do care.
Real world example of this was bottle inspection, because I knew of this company once that was doing real-time camera optic inspection of bottles on an assembly line, and they were running on C and QNX, and they were rewriting it in .NET on Linux, which I always thought was a bad idea. I don't know actually how this ended up, but it was a really bad idea because the garbage collection triggers at the wrong time, and thousands of bottles zip by you without getting inspected.
Now there is actually a way to run the JVM in a real-time mode that obeys hard real-time guarantees. However, you have to replace the entire standard library.
This is like the kind that they have running on those cards, like the Java that's optimized for smart cards type thing. It's almost not even Java other than it's the syntax.
It's really assembly because you can't use any of the complex types. It's all the basic ones.